In this video, we're going to do, as it says at the top of the slide, page 311, problem number 21. I would invite you to follow along, find it in your book. You can push pause if you need to right now. Take notes as you go, don't just watch. And also, we're going to pause and do calculations along the way, so I invite you to do that as well. So it says on page 311, number 21, small amounts of oxygen gas can be generated in the laboratory by the decomposition of hydrogen peroxide. The unbalanced equation for this reaction is H2O2 yields H2O and O2. Calculate the mass of oxygen produced when 10 grams of hydrogen peroxide decomposes. So we're going to need to write the equation first, and the equation is H2O2 reaction becomes H2O and O2. And this is not balanced, but I'm going to write this down while I'm thinking about it. There's 10 grams of this, and I want to know how much oxygen is produced. If I remember correctly, that's correct. So I'm going to put a question mark over that. But we need to go back and balance this thing now. So let's see. We've got too many oxygen. We've got too many oxygens on this side. We put a 2 in front of this one and a 2 in front of this one. I think that's probably going to take care of it. And it looks like it does. So we have a balanced equation, which is step 0 on our list of steps. Next, we're going to write down the given, which is 10.0 grams of H2O2. And we are going to change that to moles. So 1 mole of H2O2. Okay, we need to add up H2O2. So this is 16.00. This is 1.01. So 2 times 16 will be 32. 2 times that is, so we've got 34.02 grams of H2O2. Again, I invite you, if you can't do that quickly, you stop and add up 16 times 2 and 1.01 times 2 and see what you get. So we're going to take 10 and we are going to divide it by 34.02. These grams are going to cancel out. 34.02. I'm actually punching this on my calculator, and I would advise you to do the same. 0.29. Let's do that again. Not bad. So it's 0.294. 0.294, and that is in moles of H2O2. I'm kind of running out of room over there, so I'm going to have to go down to the next line. So the next thing is to take that answer, 294 moles of H2O2, and multiply by, okay, so we are changing from moles, so we're going to take whatever the moles is, it's H2O2, take the number in front of it, which is 2, put it down here with moles, and then on top goes what we're looking for O2, so in front of this is an understood 1, so 1 mole up here of O2, the moles of H2O2 will cancel out, so we have 0.294 times, no, we're divided by 2, aren't we? Divided by 2, punch this on my calculator, I get 0.147 moles of O2, and then we take that answer, 0.147 moles of O2, we're going to change that back into grams. So moles goes on the bottom down here, and up here goes the mass of O2, which is 32 for O2. You can stop and add that up if you need to. And so I'm going to multiply these times 32, and I get 4.70 grams of O2. Okay, so there is another example of a mass problem.